2017 AP Statistics Free Response Question, problem number 3.
A grocery store purchases melons from two distributors, J and K. Distributor J provides melons from organic farms. The distribution of the diameters of the melons from distributor J is approximately normal, with mean 133 millimeters and standard deviation 5 millimeters. For a melon selected at random from distributor J, what is the probability that the melon will have a diameter greater than 137 millimeters?
Take the normal CDF with a lower bound of negative infinity, the upper bound of 137, a mean of 133, and a standard deviation of 5. You should get an answer of 0.788.
Distributor K provides melons from non-organic farms. The probability is 0.8413 that a melon selected at random from distributor K will have a diameter greater than 137 millimeters. For all the melons at the grocery store, 70% of the melons are provided by distributor J and 30% are provided by distributor K. For a melon selected at random from the grocery store, what is the probability that the melon will have a diameter greater than 137 millimeters?
Multiply the probability of picking a melon from distributor J by the probability of a melon from distributor J being below 137 millimeters. Then multiply the probability of picking a melon from distributor K by the probability of a melon from distributor K being below 137 millimeters. Then add those two values to get the probability that a randomly selected melon will have a diameter greater than 137 millimeters.
The probability of a melon having a diameter greater than 137 millimeters from either distributor is 0.3475.
Given that a melon selected at random from the grocery store has a diameter greater than 137 millimeters, what is the probability that the melon will be from distributor J?
Divide the probability calculated from part B by the probability of getting a melon with a diameter below 137 millimeters from distribution J.
You should get 1.469, meaning there is a 1.469% chance, given the melon has a diameter greater than 137 millimeters, is from distributor J.
Scoring. Part A is scored as follows. Essentially correct. The probability is correctly identified and work is shown to reach the answer. Normal CDF is properly set up and identifies the correct answer. Partially correct. Normal CDF is properly set up, but the final answer is incorrect. Identifies the correct probability but does not set up normal CDF correctly or does not show work. Incorrect if the response does not meet the criteria for E or P.
Part B is scored as follows. Essentially correct if work is shown to reach correct probabilities of both distributors and is evaluated correctly to reach the correct final answer. Partially correct if work is shown to reach the correct probabilities of distributor J and K based on percentages, but does not properly evaluate found probabilities. Correct probability is found for one of the two distributors. Followed evaluation is correctly set up but does not reach the correct answer. Incorrect if the response does not meet the criteria for E or P.
Part C is scored as follows. Essentially correct. The correct probability is found and properly evaluated and provides context. Partially correct. Probability is correct but does not evaluate properly. Probability is correct but does not provide an explanation. Probability is correct but no context is provided. Probability is incorrect but context and explanation are correct. No work is shown but correct probability is found and context is provided. Incorrect if the response does not meet the criteria for E or P.
Florence Nightingale David, project by Logan Hutchins, Megan Hutchinson, Megan Smith, Catherine Turner, and Laura Traugott.
Origin. Florence Nightingale David was born in Ivington, Herefordshire, England on August 23, 1909. She lived in England until the age of 59 and was named after Florence Nightingale, who was a friend of David's parents and also a statistician.
Early life. It was concluded that Nightingale was very smart at an early age. She began advanced math tutoring at the age of 5. She also learned algebra and the languages of Latin and Greek at an early age.
Nightingale was intrigued by the subject of math. She learned arithmetic before turning 5 and learned algebra before going to school at age 10. She also continued her studies of math for 3 years at Bedford College for Women in London and graduated in 1931. At 22, she graduated with her mathematics degree. She originally wanted to work at an insurance firm, but was denied the job due to being a woman. In 1933, she was offered a job to work as a research assistant for Carl Pearson. She soon became a lecturer for the college statistics department at the University College in London and earned a doctorate at 29.
Contributions. Nightingale created statistical models predicting the outcome of bombings in England during World War II to help keep humans safe. She became a professor in London after the war, and she was also a pioneer for women to advance in the study of statistics.
David's books. She was an author of many statistical books, including The Table of the Ordinance and Probability Integral of the Distribution of the Correlation Coefficient in Small Samples. Also, A Power Function for Test of Randomness and a Sequence of Alternatives. This book investigates the behavior of the non-parametric test for randomness based on the number of alternations of events and its complement in a series of trials. Also, a C2 smooth test for goodness of fit. In this book, David examines the signs of the deviations from expected numbers to see whether they change sufficiently often. David is also known for creating original and interesting example problems in all of her books. David's awards. In 1992, Elizabeth L. Scott Award for being a powerful woman statistician. In 1954, she was elected as a Fellow of the American Statistical Association. In 2001, she inspired the Florence Nightingale David Award.
One of David's most well-known studies is her study on the correlation coefficient. She used the correlation coefficient to calculate the solution to complicated integrals.